welcome to this talk, Data Has Gravity. Cognition is a service with a distributed learning framework for performance, cost efficiency and data privacy. My name is Eric Topham. I'm the Data Science Director and CEO at the Data Analysis Bureau. We're a data science and engineering innovation company specialising in the industrialisation of machine learning. We're developing a Cognition as a Service product catalogue of pre-packaged and off-the-shelf machine learning pipelines that solve critical industry applications deployed from our proprietary distributed learning and ML ops infrastructure platform. One of the hard truths of the ML AI industry is that only 16% of companies have figured out how to scale AI. 50% of IT leaders recently said in some Accenture research that they would struggle to move projects past the proof of concept stage. Accenture estimated during this research that on average there is a $100 million ROI gap between those organizations that are successfully strategically scaling their machine learning applications and those that are stuck in the POC cycle. So why is industrializing machine learning and AI so hard? Knowing how to train and test models is no longer the hard part of data science. Making them work at scale to industrial standards is. This, however, is hindered by a number of factors. The first is a very traditionally manual development process, which we need to have a very large engineering overhead in order to put those systems into production, manage them, and effectively industrialize them. We can see that on the diagram here on the slide, where this diagram in the middle from engineers at Google tries to illustrate the degree of blue engineering overhead that needs to go around a small part of machine learning code for it to run at scale in production. In addition to this, a couple of other factors are at play. So there's an incredibly high cost of data transfer and compute when we reach the very high volumes of data that we meet within, in particular, the IoT setting. And increasingly, this distributed and fragmented data landscape that we find from the use of distributed digital devices brings a whole host of data privacy and security considerations in the face of an ever-evolving regulatory landscape. At TDAB, we like to think of data at industrial scale as having gravity. In small amounts, data is easy to move, it's easy to store, it's easy and cheap to process, and indeed the management of it is therefore relatively easy. However, in large amounts and large volumes of data, this all becomes increasingly complex and expensive. In addition, moving and centralizing data creates an ever-expanding data privacy and security challenge that on top of that is increasingly difficult to manage due to changing regulatory requirements across different geographies around the world. So for this reason, we think of data as having gravity because there are many drivers that oppose its easy and inexpensive movement. Traditional analytics and machine learning demands that we move data to a central location. We're all, I think, familiar with this idea that we have data generated in some place, we move it into a centralized storage location where we then might integrate it with other data sets and then carry out analytics or machine learning model training, testing, evaluation before eventually deploying a model back out into the wild, if we like. However, most data in the world is now generated from distributed devices, in particular IoT devices. Ideally, we'd like to avoid moving this data and carry out as much processing as possible close to where it was generated. This is a key tenet of the decentralized paradigm of data analytics. According to the decentralized paradigm, we can tip the traditional way of doing machine learning and analytics on its head. Instead of moving data effectively to the location for model training and development, we instead package up models and move them to where the data is generated from. So what we do is that we create entire pre-packaged machine learning pipelines that are wrapped up into a program so that we can deploy them locally to distributed devices. Models can train on each device, and then we can simply return back the abstracted model weights, which are then aggregated by a central server, creating a new global algorithm. At TDAB, we're building a Cognition as a Service platform that's optimized for Industry 4.0. We build pre-packaged machine learning pipelines that are optimized for specific industry use cases. These include all of the necessary ML ops components for the pipelines to train, deploy, and then be monitored at scale. These pipelines are then deployed via a distributed learning platform that leverages federated learning. This allows our customers to leverage all of the data from thousands of machines across manufacturing lines, plants, and geographies without having to actually connect them to a central data repository in order to train and deploy their machine learning models. This saves huge amounts of money in terms of data transfer. It avoids the problems of limited network connectivity, and in addition adds additional layers of data privacy and security enhancement, particularly in the context of industrial espionage. So can we illustrate this system at play? Well, one of the public case studies that the TDAB were able to demonstrate to people is using Aero-Engines and the use case of remaining useful life estimation. Remaining useful life estimation is a ubiquitous problem when it comes to the management of machinery, both within the manufacturing context, but also well outside of it, for instance, in the aerospace industry. So here the challenge is to predict in advance of a failure happening when that failure is going to occur, so that we can maximize the uptime, minimize the downtime, and optimize the maintenance scheduling of, in this case, an engine, but more broadly, machines. This is particularly difficult when we have poor connectivity of those machines to a network, and in addition that we have highly distributed devices that are generating heterogeneous data distributions. So what we did for this project is develop a pre-packed machine learning pipeline that was optimized by our data scientists for the remaining useful life use case. And then we deployed this pipeline to 100 Aero-Engines in order to train them in a federated environment and then aggregate back the weights from the models that were trained on the individual devices. This was all deployed using a Dockerized environment backed off by a Microsoft Azure platform. So what did we find? Well, we found that we could achieve federated global model performance that was highly competitive with the state-of-the-art centralized models that we found for the same data set in the literature. We found that we could massively outperform classical survival analysis statistical models and even our own optimized centralized models without moving any data. Indeed, we found that the performance of our federated models depended largely on the combination of the ML model type and the aggregation algorithm that was used, and the balance of the data in the splits that were used for aggregation across the tree of engines. And this is quite an outstanding result and really proves that for the first time you can do this critical use case of remaining useful life estimation in a federated environment, and really opens up the possibilities for applying this sort of framework more widely into industrial IoT, bringing all of those advantages to our customers in terms of minimizing the cost of data movement, minimizing model training costs on very large data sets, and maximizing the data privacy and security that is around that data, while also not having to worry about issues of network connectivity. So this is really quite a game-changing technology that we're bringing to Industry 4.0. And so this brings to the end our talk about data has gravity and how we solve that gravitational issue of data using federated learning frameworks and pre-packaged machine learning pipelines. If you want to know more about how we can help you accelerate your AI journey and how we can apply these cutting-edge federated systems and pre-packaged out-of-the-box machine learning pipelines, please visit our company website at tdab.com and have a chat to our highly qualified and experienced team. Thank you very much.